Welcome to today's video. We're going to continue our discussion of how to verify trigonometric identities. We're going to build on what we did on Friday by doing some different techniques to verify an identity. And then at the end we'll summarize how you go about this process. One thing to keep in mind, this is kind of like solving a puzzle where there's many pieces that you've been given on how to solve the puzzle, but you actually have to put them together and make them fit. So keep in mind that there are many ways to do these. I shouldn't say many, but maybe a couple. So there will be different answers from time to time. For example, in the first problem that you're given here, I'm going to go over two different ways that you could do basically the same problem. And the first way is to work with the left-hand side here. And method one, it says separate a single term quotient into two terms. Meaning, you see how you have this fraction here, 1 plus sine of x over cosine of x. Now one thing to keep in mind, whenever you add and divide it by a number, that you can split it up into two terms. It's the same as saying a over c plus b over c. It's just working backwards, because normally you take like 1/2 plus 2/2, and you'll go 1 plus 2 over 2 equals 3/2, like that. Well, now we're doing the reverse. We're starting out with the simplified version at the end and going backwards and splitting it up. So 1 plus sine x over cosine x is the same as 1 over cosine plus sine over cosine. Excuse me. And notice that 1 over cosine is the secant and sine over cosine is the tangent. And then you're done, because notice this is the same as that. The second method that we've talked about before is changing from sine to cosine. So remember the original problem is here, and basically we can work with the right hand side and change the sine and cosine. And notice, now you got the common denominator, so it's 1 plus sine of x over cosine x. And notice, it's the same. So basically, there's two ways that we did the same problem. So go ahead and work on your own to do this one. So maybe you want to pause the video, and then at the end, you can go over the answer. Basically, there's two ways to do this one. The first way, like we did before, you could say 1 plus cosine x over sine x. Split it up, that's 1 over sine plus cosine over sine. And 1 over sine, you guessed it, is the cosecant. Cosine over sine, once again, you guessed it, is cotangent. And you're done. Or you could have worked with the right-hand side and said 1 over sine of x plus cosine over sine of x, and then just get the common denominator, and notice you could have done it that way. So either way would have given you the right answer. So next we have an example where we're going to have to basically combine a fractional expression to verify an identity, meaning we'll get a common denominator. And here, the common denominator is 1 plus sine of x times cosine of x. So basically, to get the common denominator, we have to multiply this side by cosine of x. And this side by 1 plus the sine of x. and we have our common denominator. Now we have to multiply the tops. Remember, some people want to cross these out right away, but remember, if you do that, then you're back to what you started with. So multiply the top, so cosine times cosine is cosine squared. Here you're going to have to FOIL. So FOIL, 1 times 1 is 1. Then you have sine x and sine x, so plus 2 sine x. And then plus sine squared over cosine x times 1 plus sine x. Now here's where you have to be creative. Remember, it's a puzzle. Alright? And in the puzzle, we know that cosine squared plus sine squared is 1. So if I just kind of rearrange the terms so that it's cosine squared plus sine squared, because when you're adding, you can go in any order, plus 1 plus 2 sine x, like that, I can take this right here and make that 1. So you have 1 plus 2 sine x. And so basically 1 plus 1 is 2. And then notice they both have a common factor of 2, so I factor that out. And notice those cancel now, so you're left with 2 over cosine x. And remember, 1 over cosine x is the secant. So 2 over cosine x would be 2 times the secant. And remember, that's what you started with, right? Or that's what you wanted to end up with right there. So basically, you have finished the problem. So go ahead once again, stop the video, and try to work on the next one. So this one, same deal. Sine of x, you got to multiply that both sides here to get the common denominator. And 1 plus the cosine of x over here. To get the common denominator. When you do that, you get sine squared, and then here you get 1 plus 2 cosine x plus cosine squared when you FOIL. Then remember, you have sine squared plus cosine squared, so that's equal to 1. Hold on, I'm just going to write the denominator again. So sine squared plus cosine squared is 1. And then 1 plus 1 is 2. Then I'm just going to go over here to you factor out the 2, and you'll be able to cancel, and you get 2 over the sine of x. And remember, 1 over the sine of x is the cosecant, so 2 over the sine of x would be 2 times the cosecant. And remember, that's what you started with. Or that's not what you started with, but that's what you wanted to end up with. Alright, so the next method here, let's say, because we've talked about that we need to change things from sine to cosine. Well, if you look at this problem here, it's already changed into sines and cosines. So I can't really do that. So that suggestion kind of goes out the window. There's no fractions to combine, like I'm not adding or subtracting fractions, I just have a fraction here equal to another fraction, so I can't really add or subtract fractions at this point. So basically, in order to solve this puzzle, I have to get creative. And remember, because it's an equation, I can multiply or divide or do anything to one side of the problem as long as I do it to the other. Well, the suggestion here is to basically to multiply the numerator and the denominator of one side by one of the terms on the other side. So basically, so for example, I'm going to work with this side here. So I'll work with sine x over 1 plus cosine x. And basically, what I'm going to do here is multiply, since the denominator is 1 plus cosine x, we're just going to multiply by the conjugate. And remember, so here, notice how on top it's 1 minus cosine x. So we're going to multiply top and bottom here by 1 minus cosine x. We have to get creative. And because the numerator here is 1 minus cosine x and the denominator is 1 plus cosine x, we'll multiply this side, since I'm working with the left, by 1 minus cosine x and see what happens. So when we do that, I get sine x times 1 minus cosine x on the top. On the bottom, when I FOIL, I get 1 minus cosine squared, because 1 plus cosine times 1 minus cosine, well, 1 times 1, then you have plus cosine x minus cosine x, and then minus cosine squared. So notice these cancel out, and that's how you get that. Then remember, 1 minus cosine squared right, 1 minus cosine squared is the same as the sine squared. So you change the denominator to the sine squared, and now we can cancel. Notice the sine here with there. So now we're left with 1 minus cosine over sine. And notice that's exactly what I wanted to end up with. So basically, I just took this term here and multiplied it by both sides, the top and bottom, or the top numerator and denominator here, and I was able to get what I wanted to end up with. So let's try another one. So for example, here, since the denominator is 1 plus sine x and you have 1 minus sine x in the numerator, let's multiply by 1 minus sine x. So you get cosine x times 1 minus sine x, and that's over 1 minus sine squared when I FOIL there. And then remember, 1 minus sine squared, you guessed it, is the cosine squared. And then you can cancel. So basically you're left with 1 minus sine x over cosine x. And that's what you have there. So it's just a different way of solving the puzzle. So the last thing that I'm going to show you here are some guidelines. And you can pause it and kind of go through them, but basically there's some guidelines. First of all, we started out and said work with each side independently of the other side. Start with the more complicated side and transform it in a step-by-step fashion until it looks like the other side. And that's basically what we've been doing. We've been working with one side of the equation and trying to make it look like the other. And remember, I said start with the more complicated side. If one doesn't seem to be complicated than the other, then you have a choice. Second thing you want to do is to look for opportunities to apply the identities, that list of identities I gave you. You should have it with you at all times when you're doing these problems. If you don't, then basically you haven't paid attention to a word I've said the whole time. Third, try using one or more of the following techniques. So we worked on some, like rewriting the more complicated side in terms of sines and cosines. Okay, that's what we did the first day. We talked about factoring out the greatest common factor. That's a possibility as well. Then we just talked about simplifying and separating a single term into two terms. So like if you're adding, is to split it up into two terms. There should be a plus sign there. Then part D, we worked on just now combining fractional expressions by getting a common denominator. Alright, so if there's two fractions being added together, combining them into one. And then the last one, multiply the numerator and the denominator by a factor that appears on the other side of the equation. So that's what we just worked on there. So there's a bunch of possibilities here. So you need to try some of them. And the last part that I kind of wrote is very important for a lot of you because you expect the answer quickly and it's not going to happen. So basically, do not be afraid to stop and have to start over. And it basically says if you're not getting anywhere, that's okay, because whenever you solve a puzzle, there's many times where you have to stop, go back, and try to fit the pieces in again. It's okay if you mess up a couple times, just keep trying. Alright, you can't be afraid to fail. It's okay. That happens in life, and you just have to bounce back. Alright, and it says, creative puzzle solvers know that strategies leading to dead ends often provide good problem-solving ideas, meaning maybe you'll try something and it doesn't work, but by trying that, you kind of thought of something else that will work, and that is how you do it. Alright, so any questions about this, we'll go over it in class, but please keep these steps also handy because this is a good guideline for you when doing this. Alright, hope you have a good evening and see you guys in class.